You know, when you grab something at the grocery store, you expect to see an ingredient list, right? It's just standard. You want to know what you're actually getting. But what about the software that runs practically our entire world? From our phones to our banks, it is packed with hidden components. Well, that's what we're going to do today. Unpack the secret ingredient list for the code that runs our lives. So let me just ask you this straight up. Do you know what's really inside the apps you use or build every single day? If we're being honest, for most of us, the answer is probably not. And that lack of visibility, it's a massive risk, hiding in plain sight. I mean, if we needed a wake-up call, the Log4j crisis was it. It was a massive, blaring alarm. A single, tiny, and totally common logging library was found to have this critical flaw. And just like that, millions of applications were suddenly vulnerable. It proved without a doubt that one bad ingredient buried deep in the software supply chain could have absolutely catastrophic results. This is the problem we're here to solve. So, how do we shine a light on these hidden dangers? How do we see inside the box? Well, there is an answer, and it has a name. It's called an SBOM, and it's quickly becoming the cornerstone of how we build secure software. Okay, so what is a software bill of materials, or SBOM? Well, the official government definition calls it a formal machine-readable inventory of software components and dependencies. But let's be real, what does that actually mean? It's that ingredient list we've been talking about. It's a detailed breakdown of every single component, every library, and every framework, and, this is the important part, it shows how they're all connected. And that's really the whole point, right? An SBOM cuts through all the complexity and gives you this clear, transparent view of your application's DNA. It replaces guesswork and ambiguity with a solid, verifiable inventory. And that is the absolute first step you have to take to manage risk. Okay, so that's the what, but what about the why? Why is this all becoming so critical right here, right now? Turns out there are a few major forces really driving this whole shift. It really boils down to three big things pushing SBOMs into the mainstream. First up, supply chain security. It's pretty simple. We have to know what third-party and open source code we're pulling in so we can manage its risks. Second, proactive vulnerability management. The next time a Log4j happens, and it will happen, an SBOM means you can instantly find every affected app instead of scrambling for days on end. And third, you guessed it, regulatory compliance. And honestly, a huge push here has come from the government. The White House Executive Order 14028 made SBOMs a flat-out requirement for any software sold to U.S. federal agencies. That one single mandate created a ripple effect, setting a new, higher security bar for the entire industry. It's pushing everyone else to adopt SBOMs just to keep up. So, with that kind of momentum, it is crystal clear that SBOMs are here to stay. Which, brings us to the next obvious question. What does a good one actually look like? Let's break down the blueprint. The National Telecommunications and Information Administration, the NTIA, they actually laid out the bare minimums for what every SBM needs to have. And this isn't just a random list of files, it's structured data. You need the basics, like the supplier and the component's name and version, but then you also need unique identifiers, like a Perl or CPE, so there's zero confusion. You also have to map out how everything is connected, the dependency relationships. And finally, you need to know who created the SBM and exactly when. This isn't just nice to have stuff, it's the absolute minimum for an SBM to be even remotely useful. Now, when you start talking about formats, you're going to hear two names pop up all the time, CycloneDX and SPDX. Now, they can both do the job, but they come from different worlds. CycloneDX is an OWASP project, which means it was built from the ground up with security in mind. SPDX, on the other hand, comes from the Linux Foundation, and it started out focusing more on licensing copyright compliance. Which one you choose really depends on your main goal. But the good news is they're both machine-readable and have tons of support. Okay, let's get practical. To make SBOMs actually work for you, you need a solid process. Number 1, automate it. Bake generation right into your CI/CD pipeline. Because a manual SBOM is pretty much useless the second after you create it. 2, make sure it has all those minimum required elements. 3, use a standard format like the ones we just talked about. 4, sign your SBOMs digitally so people can trust they haven't been messed with. And finally, and this one is critical, generate a new SBOM with every single build. It has to be a living document, not some snapshot in time. All right, so creating an SBOM is just the first step. I mean, a list of ingredients sitting on your counter doesn't make your kitchen safer, right? You have to use it. So let's talk about how to turn this document into an active defense. And Matt Rose over at Reversing Labs just nails it with this quote. He says, without automation and standardization, SBOMs will be out of date and ineffective. And he's 100% right. The value isn't in making the SBOM once. It's in making it a continuous, automated part of your security toolkit. If it's not automated, it's already obsolete. So, where do these things actually live? Well, you've got a few options here. You can store it as a release artifact, right alongside the software it describes. Or you could keep it in a Git repo, maybe use a dedicated repository server. Another really popular option is to store it as metadata in your binary repository, like Artifactory or Nexus. Look, the key isn't the exact spot you put it, it's that your automated tools know where to find it, every single time. And this is the payoff. This is where it all comes together. Once your SBOM is stored, it gets fed into an analysis platform, something like OWASP Dependency-Track. Now, when a new vulnerability is discovered out in the wild, you don't have to scramble. Your system just automatically flags every single product that's at risk. That's the game-changing leap from reactive panic to truly proactive security. So let's just zoom out for a second here, because this whole shift towards SBOMs, it isn't really about a new file format or another tool you have to buy. It's about a fundamental change in how we think about building and shipping software. And if you think this is some far-off futuristic trend, get this. A recent Sonatype survey found that a staggering 76% of large organizations are already maintaining SBOMs. 76%. This isn't something that's coming. It is already here. And that's really what this all comes down to. An SBOM is so much more than a file you generate to check a compliance box. It's the cornerstone of a whole new culture, a culture that's built on transparency and accountability. It's about finally taking ownership of every single ingredient we put into the software we create. Which brings us right back to where we started, doesn't it? We would never accept a mystery meal with unknown ingredients. So, as we rely more and more on complex software for basically everything we do, isn't it time we all started demanding an ingredient list for the code that runs our world?